Okay, so dear Heavenly Father, we thank you for this day. We thank you for the ED break that we had. We thank you that we can come back to learn today. We ask that we shall have everything we need. May we have presence of mind. May we be able to pick up from where we stopped. May we learn. May we all have power and internet wherever we are. We ask for good health for us and for our relatives and around us. May there be protection. Thank you, Lord, in Jesus' name I've prayed. Amen.
Amen. Thank you for this wonderful prayer, Doctor. I really appreciate personally. I sometimes do reflect a lot on your prayers. There are some words that you always use that enlightens my day. And to all the students, welcome back from the ED break. I don't know how do you say it in your language, in Arabic language, but otherwise you're welcome back to our recess program. I believe you had enough time to interact with your concepts that you mastered, which we covered in object-oriented programming. We covered classes, objects, and encapsulations, but today we're going to move a little bit far because we want to complete this key concept of object-oriented programming. However, today I might change a bit because I will be able to use some advanced concepts along the way. I think in the last hour of the lecture, you would find it a little bit more interesting because, or intriguing, because I will be using some good examples that I feel they will help you understand this concept of object-oriented programming. So today we're going to basically start from where we stopped. We covered encapsulation. Today we're going to look at inheritance. Briefly, just to lay a simple foundation in a minute, what you need to know about inheritance is that it's a concept, because we looked at all the six. We're going to look at all the 6 key concepts of object-oriented programming, but inheritance in particular allows you to create a new class or a new class based on the existing class. And we're going to look at it, the new class, which will be derived class, something that we can call it a subclass under the class. That's what we're going to be looking at basically. But we'll look at simple examples, then we later keep advancing. So we can't climb a tree from top, so we're going to use the normal way of climbing the tree so that you understand from simple to complex. Then we will have our final, okay, not final, but at least an assignment for this week. I must say that people are trying so much to improve. I already made a solution for the first assignment of creating a simple calculator. So you should be able to check it out. And you will see the difference. You will see how I do it and then how you have done it. You already have the code with you, but it's a good thing. I have worked out the solution, so you will check it out. Okay, basically, we're now going to be focusing so much on writing the code bit of it. First, I want to just explain this using a simple code. Now, when you're dealing with inheritance, you will have a class, okay? Let's say we have a class. The way you see class, cycle shape and shape. So basically, you're trying to create a subclass inside a class. So this class, I'm just using this example, but what you can see here is, I just want to explain to you the word cycle shape. This one here is a derived class from what you pass into the argument of the function here, which is going to be what? The base class in what? In object-oriented programming. So you can have a derived class basing on the best class, which is shape. Shape is the best class. Cycle shape is the derived class. So this is an additional attribute or method that specifies that is specific to a derived class. So this is what you will always be using. Whenever you use this, I will know that you have implemented what we call inheritance. Okay. So let's see if we can look at it with one simple example. Then we will go a little bit advanced. Then I think that would help us understand. So I'm going to pick up a typical example of things we are familiar with. Let's first look at it in this example. We have animals, and probably we are going to represent them without the back. Like, let's look at cat, dog, and cat dog scenario. A dog barks, and then a cat probably says meow. So we can try to have dog and cat to be the subclasses or the derived classes. And then our base of the class, let's call the base of the class to be what? Animals. Animal. Just like when you're dealing with if statements, you have to terminate, okay? There is something here which we need to, okay. We'll probably fix that as we keep moving. Now, here, we have the class animal. Animal is the best class. Now we are going to initialize. And one thing that you should know, that when you're writing your program and in Python, you leave about two white spaces, 2 lines before you write the next code. That is always the good practice that you need to deal with. Okay, so let's try to look at something like this. We have to define, like, in form of eating. Okay, maybe we look at, let's just, okay, itself, format eating. Let me put this to be the print output to be self. We'll file to the self name, self.name is eating. Okay, I think it's kind of a repeated. Okay, it's not repeated, so we could probably go with this. Okay, so this is something that is going to be a little bit easier for you. We can format it. Let's have it as a formatted string here. I don't want to have it like a long written script. So I can, this is something that is generated from tab 9, but I'm just trying to organize it so that my code looks somehow better. Okay, so you will see how we will implement this for it. Now let's have, let's have another subclass. Now, we're going to have another class for dog. Okay, so we have dog, animal. Now, dog is a subclass, which is a derived class for the base class animal. Now, what does a dog? So dog, we can define a function here. We don't, no, let's just say define back. I don't want, okay. I don't want to use those generated things. Sometimes they disorganize my what? Okay. Now, this is fine. I can use this. So print, we format it to self. That means it would be, someone should mute. Okay, that means dog is barking. We'll self-check to make sure that we see the derived class shows that a dog is barking. So that's what we will try to implement here. Or you could just say print barking, or print, how does a dog bark? Eh? Dog is barking. We can just even, just for you to understand, dog barks like woof. That's how a dog barks. We'll see it in the output. Now let's have a cat, another class for cat. Cat, meow, something like that. So, but we need first to define an inheritance for class, for cat. Cat. So cat animal. So self meow. It will say cat is meow. So this is the variable name. Okay, let's now see if we can create objects for it. Let's create animal. Let's create animal objects. Okay, now this is where we can have our variables. So for animal, dog spot. Okay, not bad. We could use all this. Have no floop. Okay. Then we just have to implement one variable for animal. 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 Okay, so we can have this to be generic animal. Okay. Now, so these are the objects we have created. Now let's invoke so that we can try to see if we can be able to output generic animal is barking or is eating, something like that. Okay. Okay. So yeah, generic animal is eating. So that's how we would try to. Okay, let's call it method. Invoke the function to call the it method. Let's use invoke the call it method. Okay, so let's try with animal eat, dog barks. So here, basically, we should be able to it is going to show us when we run this, we should get an output of what the animal eats and what the cat eats. So but I think it would be nice if we just change it to also bark, because we have a class there for barking. So let's have a bark, which, let's see. Okay, so we'll check that out. So let's first run this before this is a dog. We check cat out. Now, let me first save this and then I will explain much better. It's Geoff.py. Okay. Oh. first clear everything. I've seen where the Livingston is going to teach you debugging, so you'll be familiar with some of this. I didn't write Python well, that's why it was generating that. So you always have to be keen while typing, those type of thing. So here you see Spot is eating, Spot is barking, woof. Because we invoked this function to call for the call method. Let's look at to call the eat method. So the eat method here is for barking. All right, now let me explain to you in a simple language. Now we have a class which is the best class here called animal. Now this serves to be the best class that will be representing the generic animal. This one, when you invoke from what we created in the variable. And then we have another subclass which we created here, dog, okay, which is a derived class, which will represent from the variable we created, dog. It's going to be this variable. Then we also have another subclass that we created, which is cat, which is going to, from the object we created, cat. And if we invoke, it will be able to print what is within the cat here. So now let's try to print cat. Cat eat. Then cat meow. Okay, so let's save that and clear and then rerun. So you can see Floppy is meowing. So this method is invoked to call on the cat, where we define cat self meow using this method. That's why you see it is printing the cat is meowing. So it's how you derive the function from what is being inherited from the classes. So that's why we say clearly that when you're dealing with inheritance, you just creating a class, a derived class, to help you create a base on the existing classes. And now this helps you to inherit the attributes of the method of the base class. And then in that way, you can reuse your code to create that relationship between those codes. That's why you see it is able to what? It's able to call and then print out that output. Now let's try it with one more example, which is going to be slightly advanced, but it would be nice if we try it. It won't be also difficult, but you will understand it much better. So let's think about a typical scenario of example 2 in a car form. Now, because now I'm dealing with example 2, I'm going to demonstrate inheritance using example 2. And I believe from example 1, you should be able to pick up the concept easily. Then you can try with one more exercise. So we are just demonstrating example 2. We are demonstrating just inheritance. I told you one good thing is when you comment, it helps even to understand what you want to. They call it Copilot. Copilot helps to understand which type of script you want to write. Now, like now, it's just using tab 9, then it displays that code. But we don't want to repeat that same example. we're just going to look at a situation like dealing with a car. We have maybe to display car move and then car info, like when you're honking a car, some example like that. Then I think that would be much easier. First, you need to create what they call a class when you're using inheritance. So this class, we will have a class vehicle. We're not passing in animal, sorry. It's just going to be vehicle. Now that we have, you see, Copilot is suggesting for me what to, now it's telling me to define and initialize. So, okay, I just press tab. So I have self brand, self color, which is okay. Okay. Then we can now, we can have, okay, it's suggesting. So let's go with that code and we see if it is not what I want, I will change it always. Because it understands that I'm demonstrating inheritance. Now here, what is trying to show the display, can someone mute? Display underscore self, okay? The display underscore self is not yet an inheritance. So this is where we are going to implement the inheritance from. We're going to implement it in the derived class. So we can have a class for car. So this car here, which we will pass in to inherit the attributes, all these attributes, brand, color of this vehicle. That's why we're now using inheritance, so that it helps us to pick the attributes from these parameters. Now we are now also going to do to what do we want basically from the car? When you check using tab 9, here it's suggesting, okay, brand color, number of wheels. Okay, we could go with that. But there's something we can also try to see. We can also define one more to get for us if a car moves. So that prints moving vehicle. All right. Now we have one class for car. Now this is checking the variables that we have. Okay, I hope that is okay. Then let's define one more time for the vehicle info. This shows number of wheels. I'm just using tab 9, but I'm going to just be able to explain this all to you because it's just suggesting for me. Then honk, the car is honking. Okay. All right. I think that is nice. Now, we can now create object always. Let's create car object. Now in this car object, it's going to be my car. We can have the car, my car, red. Okay, that's okay. We can go with that object. Now let's see how to access and modify the attributes. Attributes. All right. It's still going to. Now here it's changing. We are modifying the attribute by changing the color to blue. So you use the print my car, the output will be Toyota. That's good with tab 9, which is being suggested from Copilot. Now let's invoke the method and see the output. Invoke this car method and see the output. Let's see my car. My car. Okay, let's use display info. So now what do we have in the display info? it will show the brand of the car, the brand and the color of the car. But remember that we modified the color of the car from this object that we created. We changed the color to from red to blue. That means if we run this output, the brand will be, and then the color. Oops, which is okay. The other part of the code is still active. Okay. Okay, run it one more time. Okay, so the brand of the car is Toyota. The number of wheels, this is the number of wheels, is 4. And the color, because we change the color to be blue. What if we change the color to be silver? Okay, gray. That means when we rerun this, we expect the color to change, because when the color changes to gray. But originally we created the object for my car, which is showing the car the car info, having the color and then the number of wheels, based on what we define, okay, on the car, to get the attributes of the car: brand, color, number of wheel. This is where we initialize it in this parameter, so we do not miss anything. Okay, so now what happens exactly with inheritance? Because now we created what we call vehicle, which is the base, okay? Now, in vehicle, we represent the generic info, like brand and color of this vehicle. And then we also created a method to display this method here, which is used to display the information of the vehicle, okay? And we've not implemented the move, okay? But we can try and print it here and see, because we also created a method to move, to see if the vehicle is moving, to display if a vehicle is moving the vehicle. Then we also created another inheritance here for cars. This is a derived class from the base class vehicle, which will inherit all the attributes. So this car here will, this derived class car will inherit what we have in the class for vehicle. So all the method for info, brand will all be inherited when you use the word car, vehicle. That's why inheritance will just help to pick all the attributes of what you have defined on the base. So that's how they implement inheritance. There's one example that I want you to try. Let's first see if we can display this method move, and it prints car moving. So let's see if we can invoke the method on the car, on this car, okay? So that we get it to display car moving. So my car move, when I save, it should show me some output that car moving car. Oh, okay, vehicle moving. Because this, when you invoke, you'll be able to display that method for move, okay? Then let's see, we implemented something on other car, onc. So let's invoke and see if it is able to onk, like onking the on, we can come here and say from the variable my car onks. Then when we come back to run this, should be able to show us that my car onking the car. So this is a typical scenario how you can use inheritance, which allows you to reuse the code from the derived class to inherit the attributes and the methods of the base class. And then it also helps to eliminate the process of you rewriting the code. And it helps also to promote how you can have an organized code in a way that it's in a more model relational classes. Okay, the classes are relational. So you see from car vehicles. And that's the importance of using inheritance. So I want to give you one simple assignment, not difficult, simple. Let me pick, and you just implement the inheritance concept and make sure it is able to let me see on this exercise. I'm just going to check it. The weather is changing. I hope power doesn't misbehave after all what we have lost. Okay, let me try to get one more simple example. Okay. So what I want you just demonstrate. Okay. Demonstrate using inheritance to calculate let's see, we calculate we can calculate area and perimeter of cycle and rectangle respectively. Okay. What I just want to guide a bit on this to make it easier. Just create the base class to be shaped. Okay? Okay. Just create the base class to be shaped. And then you can use the method to help you get the area and then the perimeter. Then you can invoke to display your result. Those are the only things. You can invoke the method to display your result. Those are the only things which I expect you to try it out. So I'm just giving you a break of 3 minutes. It's not a break, but just try it out. If you feel you're ready, I stop sharing the screen. And then what is good is that you already have Copilot. Copilot is going to suggest for you. You may run into error, but you will be able to show it here. Just calculate the circle area. Probably maybe just use any width and length for the rectangle. And then for the cycle, just pick any radius. That should be able to to make you do that calculation. But what I know is that Copilot will auto-generate some code for you. You should be done by now, because I've also been using Copilot. I've not been writing all these codes, but I know what I am implementing. I'm just implementing inheritance. Okay, just let's have that, and we see what you can share briefly. Then we can look at one more example on inheritance. Then we can now move to another concept. Anyone who has tried it out? I'm now going back to the chat to see if there's any question. Okay. I'm going to stop using Copilot a bit with this example. What is the exercise? That is the exercise. The method, okay. The method would be to get the length and width. And then one method which will be to get the radius. The radius of what? Of the circle. The same Copilot is making me to be very fast. I'm going to slow down with this example. Okay, try to share your screen. If you have a problem, I'm going to be slow. I'm going to type all the codes on this exercise. If one person can do it, better. If no one can, then I'll be able to do it myself. Try to unmute and also explain briefly how you have implemented it. I know it's not difficult.
Good morning, sir.
Good morning.
Yes, this is a leadership Brian. So this is how I have implemented the exercise. I created a class shape which is having the variable length, and then created another class circle which is inheriting the property of length because of length, that is of the shape. Then I've defined new methods here, the area and the perimeter for the circle. Same for rectangle, but in this case, I've added a new variable width. Because for rectangle, it has the length and the width. Then initial define the width here, and then this is a formula for the area and the perimeter.
Okay.
And then here I've created the object of a circle, and here I've created the object of a rectangle. So here, when you call for the method of the area, it will go to the area of the circle that you defined here. Same applies for the rectangle, the perimeter and the area. It will call for the method of the rectangle defined within the class of the rectangle. So if you try to run it,
first scroll down.
so the area of the circle is that, perimeter of the circle is that, area of the rectangle that, and perimeter of the rectangle is that.
Okay. I like your example, but it would have been nice. First scroll up a bit. It would have been nice when you're calling the method for cycle, you should have used radius. Okay. When you put it like length, it gets a little bit confusing.
Okay. So I redefine it here.
Yeah, just redefine it because like people want to learn. So we can use your example for teaching. So radius, I don't think that is the correct spelling. It's raining. I hope power doesn't interrupt this morning session. Would have lost twice.
Oh, like that.
Yeah. Okay, that's fine. No, that okay. That's okay.
Yes.
Now people first scroll down. So okay. So now you see circle, you pass in the radius to be 5. Not so?
So the radius is 5.
Okay. Okay, that's nice. So I think this makes it much easier for people to understand. For those who are saying I'm fast, I'm sorry, I'm not fast, but you just need to get used to this. I think you need to look at the attribute for cycle, which is supposed to be, looks like now it's supposed to be what? Supposed to, you've modified it. That means it's supposed to, just check it one more time. Have you fixed?
Ah,
Okay, you stop sharing. Let me do it. Let me do it because so that people can follow. Okay, guys, I'm going to be a little bit slower so that you understand. Oh, Zara is sharing.
Hello, can I share or you're going to
It's
explain?
okay. It's okay. You share, then I'll.
Okay. This is how I did my example.
Mm,
Since we learned models in the last lecture with Mr.
yeah,
Livingstone,
yeah, I
I
expected
imported
that math model. Okay.
yeah, I imported math, which is a module. Then I've been using the word pass in child classes, or it is used when you don't want to inherit any methods of the parent class. So I had these functions of calculating area and calculating parameter in the base class. Then I had to create a class called circle. Of course, it's inheriting, it's a child class of shape. That's why we passed in shape as a parameter. Then this is its constructor, which takes in only the radius. Then I will have to call these methods of the parent class, which are calculate area and calculate parameter. Then I use math.py. Since I imported math, so as I can use py. If I don't use it, it will return an error. Then the same applies to rectangle. I created a child class rectangle of the parent class shape. Then this is its constructor, which takes in length and width. Then I still override, I'll call it overriding the methods calculate
okay.
area and calculate parameter. Then this will return the length and this will return rather the area and this will return parameter. Then I had to invoke, rather I had to first of all create the instances of those child classes, then print out my methods. Yeah, so this is my output. I can rerun it again.
It has worked, huh?
Yeah, it has worked. You've not seen?
Okay. I've seen.
Let me show you again. Okay.
Abraham fixed the code.
Yeah. Okay, I'm going to be short and brief. I don't know whether I'm loud enough. It's kind of raining here.
Yeah, we can hear you.
Okay. Yeah, here is my class. I have the super class, which is Geoff. And then, okay, let me first try to reduce the console window. Now I have the Geoff class, which is having the constructor init, and then the area, and we also have parameter with the variables which are declared. Now the area is returning the formula which is given here. Then we have the display, which just returns only the radius. Now I have the subclasses, of which the first class is cycle, which extends the Geoff class. And then I'm here calling the construct of the superclass. And in that cycle, I have also the area to the formula, which returns 0.14. And then, so yeah, I'm multiplying the radius 2 times. And then also I have the parameter, and where I returns 2, then times 3.14, then multiplied by radius. I also have the display method, which returns only the radius area, then the parameter. Now, we also have a rectangle class, which extends the shape. And then,
Okay. A tongue went off. Now I like it the first time when I introduce the concept. It sounds like it's difficult, but it's simple. Now I want to simplify it. I've seen Zara try to use polymorphism of passing. We're going to implement that. Zara, you're one step ahead of your colleagues, but I'm going to explain to you. Under inheritance, there are 3 areas that you need to understand when writing them. I just brought that to trigger out your thinking and see how you can logically understand that concept. But I'm going to, the first one, there's what they call multiple inheritance, and then we also have what we call method overriding. Then we also have what we call hierarchical inheritance. So what we did was literally hierarchical inheritance. So let us now look at it like under each concept. The first one is called multiple inheritance. All right. Someone was saying that I'm using Copilot a lot. But still it's going to be the same thing, but let me try to write. I'm just going to type the codes. I'm not going to use the tab 9. Seems like only one person complained in the chat. There's no any other person who complained. Now, we are going to create, Zara has been using the child and the subchild under classes, but some books normally refer them as the best class, the derived class, and then the best class. So whichever way, it's okay, as long as you understand them. Don't be so rigid and static, okay? But just be flexible with the way how people use the words. Okay, so if we create a class, let's look at this example where an animal is eating, a bird is flying. Simple as just simple methods that we will use. First, let's have what we call a class for animals. Okay. I hope I'm not fast this time. Now, in this method, it's going to someone saying that I'm using Copilot. So this Copilot here is just going to, when you press tab, which I know you don't want, it's just going to pass in the parameter for self and animal check, which is, this is a method. Okay, you're defining a method. Then now what you're going to do is you're interested in what is the animal eating. This is what they call multiple inheritance. So it will self, because even if I type everything like the way you see it is already suggesting here. Here, what we are interested in, what is the animal eating? Here we just say animal, check animal. So we have the class. It would be, we will create a variable, okay? So that we can have animal is eating, okay? That's what we're going to do. And it's going to be in our print here, animal is eating. That's why it's easier when you define this method, press tab. If you have a problem, when you press tab, just point to it. When you point, you have defined a method, it. You see, if you have a problem, always with tab 9, try to push your cursor on it. And I believe we have been doing these things, you now have understood a bit. So when you have the method animal here, what do you want to output here? That's why you have the print. Print, it's going to check the parameter self and then the variable name. As simple as that, because self is what is inside the parameter. And I think that's how it's supposed to literally be explained. But you can't explain this code by just pointing like this. You just need to understand what do you want, what are you implementing? Because here we are demonstrating what they call multiple inheritance. So we have the first method for it. Now, animal eating. Then we are going to have another method for maybe like bird flying. Then another method to display bird info like species. That is it. And then we can have another they call it derived class, child class. That you call it child class, derived class. That's the same thing. Now let's see how we can implement that. Okay. Now we're going to have another class. Like now, this tab 9 or auto copilot, it's suggesting what I don't want to use. In that way, I want to create my class, not dog, but my class is going to be flyable. Okay. Now, Copilot doesn't know. Right now it doesn't know what I want to implement. Now, here, when I say define, now Copilot we know that, okay, maybe I want to get another method for fly to show flyable. That's why now it gives me another method with a parameter self to self-check what is initialized here. And then the output is going to be, it will self-check and show maybe what if we declare another variable to show the variable. Then if you want to create now, because we haven't used inheritance yet, but we just want to, I want to implement what they call multiple inheritance. Even right now, Copilot is suggesting, you see, it's it is inheriting animal and flyable. This is what they call multiple inheritance. But I don't want to I don't want to use it in a class called dog, because I'm not dealing with dog. I'm dealing with maybe another class. Let me probably use another example here, like bird. Okay. Now, inside bird, I can now implement what they call multiple inheritance by bringing in the class, passing in animal to the argument animal and flyable. Okay. Now, because this particular line of code that I've written here is the one which is now called multiple inheritance. So I'm inheriting the class for animal and this class for flyable, which I explained that this class here is called, it's called the best class. And then the derived class is bird, which is inheriting the best class, animal and flyable. That's why when you point over it, it will help to explain to you to understand very well. And that's how you will be understanding most of these codes yourself. Just know here, the child class is passing in, is inheriting two classes, the one for animal and flyable. Then you are defining a method. Okay. So when you define a method, you initialize initialize, this is fine. All right. The only thing here it's looking about probably wings. Maybe you want to change your variables here. Instead of having it wings, I can have my variable what? I can change it here to species. Then this also becomes what? Species. Hope the spelling is all fine. All right. Now, the only thing that you have here when you point on it, you have a variable called species. Okay. And the parameter, it's self-checking here. Bird, it is self-checking. I'm just explaining this code slowly. It's self-checking the class bird. That's why you put bird self dot species to self-check that variable. Okay. All right. Then from there, because we changed this to, it's complaining, so we need to change this to what? We need to change this to species. Otherwise, it won't work. The method to display the info. Here we're dealing with species. If you don't, it won't. Now you see it has stopped complaining. And basically that's how you go by the rules. Okay. Then now, what do you want to display? Like you want to display the info. So def, I'm going slowly. I know I've been fast. So here you display. You display, let's say info self. Now, what are you displaying? You would probably use this super display species. That is fine. Then you can also have print one more, print. This time species dot that, but you could do it to check name. we will create another variable for name. Oh, it's already there. So this is going to be, okay. So Copilot just helps you to save time and gives you the best way out to write your script. Okay. Now, we have displayed that. We now need to create object, because we need to create the bird object, which is going to be my bird, pigeon bird. Okay, pigeon bird, which is fine, unless you want to have another name, probably instead of pigeon bird. You could also have they call them, I did some birding, so it's called the is it the family? Pigeon is under the family of bird. Okay. Now you now want to invoke the bird method so that you can be able to display. So you can have all this. Bird eat. Do we have eat somewhere? Yeah, we have eat. Bird eating. Then bird fly. Do you have fly? Flyable. Yes. Bird flying. Then display bird info. Yeah, as simple as that. So once you come on to your command line and okay, displaying some other stuff.
Maybe it's a
Okay. Do we need this? I don't think so. Okay, so those errors will always be there as a programmer, but you need to learn how to fix them. Livingstone today is going to teach you debugging. So sometimes you see, because I used tab 9 and I accepted it to have the display method for display info. Now, when I decided, when I decided to run this code, okay, let's see. Yeah, I was getting this error. Attribute error, super object has no attribute, display info. So, but it was printing the other parts. That means this wasn't even necessary. I had to just remove it off. Removing that would help solve this. You guys are programmers, so you know some of these things you will always be experiencing them. But now, what am I explaining here? I'm explaining one concept. All what I've done here is for you to see the implementation of what they call multiple inheritance. And how do you implement the multiple inheritance? This is how you implement it. This bird here is a child or a derived class for the base class of animal and flyable. And this small part here, it is just one line. No, yeah, one line It's the line 2. This line is 211. It's implementing one small concept called multiple inheritance. Next time when you're dealing with inheritance, you know, okay, if I want to implement multiple, I can pass in my classes, okay, inside the subclass. That is the concept of multiple inheritance. Then there's another concept which I'm going to introduce right now. It's called overriding.
Excuse me, sir. Excuse me, sir.
Yes.
You can go back to the display method. What if you remove that super.display info?
If I remove what? Super?
That line of code.
I don't think there's a problem.
Then you run your code.
You get
yeah, then you call that display method and run the code.
It will work. It will work.
Okay, thank you, sir.
All right, because you see, these are kind of like a tab 9 generated. So you just need to understand the flow of the concept. So it will definitely work. Okay. Let's now look at overriding. Now, you see, right now we are interested in one small concept. The concept is called what? Override. Method overriding. We are overriding method. Now, the moment you're programming, that's why I've always been telling you that always, if you want to be very good in writing this code, I know you'll probably spend few time debugging. When you put like method overriding, and you know why we use this AI tool is just to help us not to spend a lot of time, because when you write those codes, you end up having a lot of errors. But it's, in fact, most people reuse codes. If you know that, let me just say it in this way, you know, Stack Overflow. Almost all ideas that you want to implement, someone has implemented the solution and it's there. If you cannot read and understand somebody's code and reuse them, then I don't think you're going to be a good programmer, because there's no any new code that you can write. Most of these codes are written. That's why we have Copilot to help you automate the process. And tab 9 is just for you to accept. Now, once you accept that, that's why we are teaching you all this programming concept, small concept at a time. We're not introducing all these concepts. We want you to understand now, okay, when I talk about multiple inheritance, you know how to implement it. When I talk about overriding, you know how to implement it, okay? That is the most important thing that you need to understand, especially when they are introducing this concept. Now, in this particular, we will still use the same example, which we used previously, so that the code does not become wild. If there's anything in the chat, let me check it right away. Because I was fast, I've slowed down. Okay, I think which is solved. Okay, they're talking about power, and nothing is related here. You guys don't mind. The first part, the problem here, I know, is that I start with an example. And the first example is always a problem. But as we keep moving on, people start understanding these things, and the pressure reduces. Because some of you are not happy looking at some of these codes. When you look at them, you start panicking, which is not a good thing. Just understand the small concepts. That's why I don't want to overuse words to explain. I just mentioned like a class because we talked about a class. Now here we have a class for animal. And this first class that we are calling it is the best class. Now, if you're going to have a derived class, then you will see how we implement. Now, in the next line is to have what we call a method. Okay. Now, in this method, it is initializing. Okay. To self-check this class. And then we have a variable. Self is checking this variable name. Now, that is okay. But if you also don't want to have it like that, we could change, because since this thing is always generating using some standard, we could even write our own in any way. Like, let me try to be unique this time. I hope we won't be getting errors. Let's say make underscore sound. Then now I'm implementing the same concept, but in a different way. Okay. Now here, what I'm interested in, print, and the output, it's suggesting for me, I'm just going to pass a string. Animal is making a sound. Okay. So that part of the class is done. It will display animal is making a sound. Then another thing that we are going to look at it is we're going to have another class which is having a derived class for animal. Okay. Now this class here, it's make sound. We're going to print dog is making a sound. Do you want it like that? It sounds awkward, but we can change it and say dog is barking. Dog is barking. Dog is barking. So this makes sense, because dog barks. Dog is barking. I'm slow because that's what you want me to do. Then it's suggesting something. A cat is meowing. Okay, now this makes sense to me as a programmer. I don't need to type this. I just use tab 9 because Copilot has automated that. Probably, maybe I want to define another class, cat. Okay, I accept that. Then this class here, this cat here is what they call a derived class, or a child class. Now to the animal class. So def make self print cat is meowing. Now okay, so we have done that, but we can also define, I hope we won't define make animal underscore sound, just to make it unique from the first one. And then we pass in animal. Then animal makes sound. Okay, that's fine. Now we have that method. So the next part is going to be, we need to just create objects. So we are going to create objects. Okay, which not dog objects, because the objects are many objects. So let's see. First have animal. Just be careful when you're typing, because sometimes these things auto generates what you don't need and you end up getting into what. So we can have that method. What the heck? One is over knocking here. Okay, sorry for that interference. You know, sometimes it's annoying when people over disturb you, like these solution things. I know you guys are IT things, so every time people run into problems, they come and be knocking your door. It happens a lot, but that is working. Just forgive me for that. We should be able to proceed. So we have created an object, animal, and now we're going to create a variable dog. Okay. All right. So we're going to cut to override. Okay. So now, when we are calling make animal sound function, this one, it will help to override this method here, make sound. Okay, because we already have wanted to override the version of make sound when it's executed. So now make animal will now override and display. It will override this method and display animal is making sound. And then make animal underscore make animal sound. It will override this and then it will display the output. So let's try to override it. Let's now implement.
I have a question.
Yes.
My question is, I thought in overriding, we don't change the method name, but I'm saying here, you said it should make animal sound. You have already changed. This is a different method. So
Make what?
like what I learned previously in the overriding is we don't change the method name.
Oh, sorry, this guy is far away from what we are talking about. This is called method inherited, but we are using what they call method overriding. Try to understand that the words are similar, they will confuse you forever. Now, let me explain to you. What we are trying to do, we have two classes here. We have a class for dog, okay? The subclass. I'm explaining it in a simple language. I want you to understand. The concepts are similar, but they will confuse you forever if you're not careful. We have what we call what? We have what we call dog. We have what we call cat. Now, classes. We have these classes here. Now, this class will override the make sound. It will override the make sound. This make sound method. This make sound method, which is inheriting from animal. Now, that's why when you call this make animal sound function with these objects that we created, it will now be able to what? Override and print the output. So in other words, that is what they call method overriding. I'm going to explain one more time. Okay. That's why you need to be very careful with these concepts. You see, they are closely, but they can confuse people a lot. But let me explain it one more time for any other person who has not understood. Okay. So in this example, which we have done, which we are almost about to finish, okay, we have subclasses under inheritance, method inheritance, which is inheriting from animal, from the class animal. But what we want to do is that the subclasses cat and dog will override the make sound method that we created. Okay? And when we call this function here, which I'm about to implement, okay? When we call, okay, calling make underscore sound. Okay? So make underscore sound function, calling make function, this particular make animal sound function with all these different objects, okay, it will invoke and execute the object here which we have typed. That's why we have make animal sound. Now the object here which we have typed is what is inside. That's why this thing is able to what? So it's now going with what we have typed here, the object which we have typed, animal and dog. All right, so when you save this and run it, I don't know, but okay. So when you save that, okay, it's okay. You see animal is barking, dog is barking. So let me take one question and see what we can do. Let's take question. If it is there, we go for a break of 9 minutes and come back and we complete hierarchical inheritance, which we have already done. Then we go to polymorphism and then abstraction. If you can't, you can type it in the chat if it is not there.
Yes, sir. I have also a question.
Mm.
Now, for example, if you are to just like, instead of creating another method, which is make animal sound, after creating the object, like a dog, you said dot make sound. Will it not call that method which is overridden?
Can you try it and then you see?
Okay.
Try it. Some of these things you need to try them practically.
Thank you.
Okay, let's go for a break of 8 minutes. Today we are going to have only one break. Then when you come, I finish polymorphism and abstraction. Okay, we're resuming back. Let me grab a cup of tea I'm explaining very slowly because I start very fast, reduce the speed, and then everyone is on the same is on board. Okay. We will finish. They're not so difficult. We will finish. Okay. You have covered so many things, so we'll resume in 7 more minutes from now. Recording has resumed. Perfect. Thanks, doctor. I'm not fast today, so trying to make sure that we go properly, but we're about to get done. Just 1 or 2 concepts with examples, exercises, and we can now get started. So I repeat, one other concept that we are going to look at, the key concepts in programming. I know you have so many programming languages that you've learned and it's in your mind, but the words are similar, the concepts are near to each other, but just learn how to implement them. Okay. Now we are going to learn about this simple concept called polymorphism. Okay. Now I'll explain it briefly. We're not yet writing the script copilot. Okay. So what this concept refers to in key concept in object-oriented programming. 1, can I use the simplest word in one statement and you understand it? Okay. The simplest statement I want to use, I don't want to use too much English. No. Polymorphism allows you to write code that can work with different types of objects. That is it, and helps reusability of your codes. And then you will also have that flexibility. Okay. And then you can also extend the use of the code. But one thing that you should know, let me actually type it here. Allows you to write code that can work with different objects. Okay, that is it. So once you understand that simple concept, the rest I'll just make it much easier for you to understand. And you know one thing, when I introduce a concept like this, straight to an example. In an example, people start, but right now, of course, you're comfortable. But at the start, I was feeling it. The good thing now that I've been doing this research for some time, I really feel that the students are understanding, they're being left out, or they're too fast. So I have that instinct that tells me, slow down, go fast. So now I understand this teaching thing now much better. Even when something seems to be obvious, I would always have to come back and explain because we have implemented all those concepts. So we'll always try to come back and explain them. Now, for you to achieve polymorphism, there are two things that you need to understand. Those two things, they are methods that you will use. And when you're using those methods, you can do what they call overriding and overholding. You do what we call method overriding and then method overloading. Now, we're going to be implementing these two key concepts. But sometimes it's going to be tricky because we have used overriding somewhere. Now they want to really see, we have just used it here, method overriding in inheritance. Now in polymorphism, we are also trying to use method overriding. How is it different from inheriting? Okay. And I said the basic thing, it allows you to create code that can work with different objects. So let's see how we can try to implement overriding. When does it occur? Okay. And then overloading, when does it occur? Maybe in simple word, let me try to explain them. Overriding in polymorphism occurs when a derived class provides its own implementation of a method, okay, to the base class. Some people call it superclass, to the superclass. Superclass, child class. I think Zara, you love using the word super child class and superclass. So you would know which one is the superclass. I'll also try to use that. But some books that I've been reading, they say that base class, derived class. There's also the base class is the superclass. The derived class is the what? The child class. Okay. I think that is much easier. I'll be using those two words all the time. I think it will be much easier. Then method overloading allows a class to have multiple methods with the same name but different parameters. So take note, this one, let me write it here so that you understand it. This one allows you, not even, let me not say allow you, allows a class to, you see, Copilot is suggesting, but me, I just want to write it in my own way. It allows you to have multiple methods with the same name, but different parameter. Now, that is it. Now I'm breaking it down to make it easier, because sometimes when you write it, it's also easier for students to understand it. Then method overloading. Now this one, it occurs when a derived class, when a derived class. Now I'm calling it derived class. You can call it also child class. Those two words, Zara mentioned it, but now I told her, I said that she was ahead of other members. Now I'm using it concurrently. And then when the derived class bracket child class provides its own, let me just come down a bit, its own implementation of a method that is already defined in its, they call it subclasses, that here we call it child class. Let me use all these words here. Subclasses. That is, it's already on its subclasses. So when I say subclasses, I'm referring to derived class, subclasses, and child class. Define is it let me see, am I getting it? Define in its, no, in its, this provides its own implementation of a method that is already defined in its base class. So we refer to the base class is the same as superclass. Superclass. Okay. Okay, I think that is okay. I think this helps to understand the concept. Let's look at example. Example 1. Is it example 4 now? But it's example 1 of what? Of this part that we are dealing with. We're going to play around with the other simple example that we looked at it in shapes. No, in that. Okay, let's deal with circle, calculating areas of circle. That same example that you implemented. But we are implementing it in a different way. The kind of the code we are writing now, even the method, we are now not initializing. Okay. Now, so we're going to have first, we're going to have a class. My class, no. Let's deal with what we already have. Same example. We're going to have for shape. Now, I've already said that shape is the superclass or the base class. Now, when I'm referring to the base class, that's why the words were Sorry, my data got depleted. I've just connected to another mic. My data just got depleted, so I've just connected to another network. Okay, sorry for that. I don't know if you hear me, please can you unmute so that I can really confirm.
We
if
are
I'm back.
hearing you. We are hearing
Yeah.
you.
Okay.
Okay, but,
Yeah, it's okay. Oh, you could now turn off. Now, there happens a lot, but not in our class today. It's just have to finish this concept. So I was explaining. No, just turn off. I was explaining one other concept which I normally use when defining a class to calculate area. So we're going to have a method for we're going to use a method that can abstract, which needs to be overridden, because we're going to begin with overriding. At least we have implemented that. It's the same thing. So let's see how we can have that. Let's have calculate. We're using the other same thing. Example, calculate area. Then, all right. Let's just pass. Just a second, I pick this drive. All right, let's proceed. Pass. Okay. So if this method is not there, I'll just go to the next method. Now let's see how we can implement for. We created a class for shape. Now we want to create a child class for. Can we? I think is it? I can just use tab. Okay, but no. Let me just write it. This thing may disorganize it a bit. Let me just delete a bit up to there. Okay. So we have another the subclass or derived class or child class that is referring that we pass in our superclass. Now we're going to have a method. We're going to define a method. Now we're defining this method. Let's initialize. Let's initialize. Okay, let's initialize. Self-check XY. Okay, the X can be, let's call it length. Now you see Copilot still doesn't know how I'm writing the code. So it can't suggest anything. That's why I'm just writing it the way I feel I should. Okay. Then make sure you put a colon. And then we don't need this super to implement. Okay, we can just implement self. Then you can just have the variables for length and width. we have over indented. That's why I have that error. Livingston will be showing you all this debugging. Now it has stopped complaining. I'm just writing the codes so that now you don't say I'm too fast. Okay. Then we need to calculate area. Okay, let's confirm that that is fine. We are calculating. So this is going to be length, this variable length times width, which is okay. Okay, so let's see if we can have another class. We now have two classes. The second class is here. We have two subclasses. So we can have for cycle, for shape. I'm sure now you're familiar with the code. Then def initialize radius. Okay. Then you have the variable for radius. Okay, that's the parameter. And then here is the variable passing in radius. That's fine. Please, if you don't understand the code, just point over it. You understand this is a variable, this is a parameter. This is a parameter. This is the parameter radius, which is this. Okay, just do that always for you to get used. And now we need to we need to what? We need to calculate the area. Remember, I'm not importing any model. That's why I'm just having I'm having this returning the pi 3.14 times the radius times the radius. So you see how it has implemented this other part times radius times radius. But as a programmer, can't we implement it in another way? I think so. We can just, we did something on operators. When I put that, I think that helps to solve that long line of a code. So I'm just writing it myself. That's why I'm moving it slow. I'm not using tab 9. And I also think and look through the code so that I don't get any error. Then we're now going to define another method to calculate. We're calculating, probably let's calculate the circumference of a circle. Calculate radius, no. Calculate circumference. South, that's nice. So, okay, it's going to be 2 radius. All right, that is fine. Now, what do we need now is to create shape object. Okay, so which shape are we going to have? Tab 9 is suggesting for me shape 1, shape 2. Okay, so let's first pick all this, but I don't need this. I needed to create shape. Let me just create this object and say this is rectangle. With lowercase. Then this is cycle or circle. Okay. All right. We still don't have any error. That means we are still going on well. Okay. Now, let us try to calculate and display our areas. This part here is just to calculate and display the area. That means we are going to look at the area of a rectangle and the area of, so print area. Okay. It has proposed for me this code. Now I can just bitify by putting in the string for the words to be readable, because it's just going to be area, which is not going to be nice. So I can just say area of rectangle, area of rectangle, and this should be area of circle. But it's kind of weird. What if we just write it like circle area and rectangle area and save that. So we added to calculate the circumference, but let's first have the display of this. Now, can now explain this code first briefly and then understand how we are implementing polymorphism. So in this example, shape is the best line of the code, which I've explained. So we're now using the abstract method to get the area of the area, which can be the area of a rectangle or the area of what? A circle. And we've also used, did we use anything like okay, so that's what we've used. So we can calculate rectangle and circle basically. And now this will allow us to use the class for shape that will help to promote reusability of this code. So let's now try to run it and see. Okay. Okay. Can comment this other part so that we can see what we have implemented. So this is how we've implemented, we have demonstrated by treating the circle as different classes. So this, we have treated the rectangle as a different class. And we have also treated the circle as a different class. Then this is where polymorphism comes in, because you want to understand, okay? So after treating this class rectangle as a different class circle as a different class, now we have also decided to demonstrate it by treating the objects here as also what? We have treated the object also differently. That's why we created these objects. To those different classes that we have the class for rectangle, which is this. We have a class for circle. Now, both of them, what do they have in common? What does the rectangle and the circle have in common? They have shape, which is what? Rectangle they have shape, which is the shape is the superclass. Is a superclass or the baseline class. Okay. If I've misused it somewhere, I would correct it. Yeah, it's the superclass. So I've written it nicely there. So it is the superclass that now helps you to have this code work interchangeably. Okay, that's why now this code is able to work interchangeably. Rectangle area, this code here, it can work, the code calculate area, this first line of the method can work interchangeably. Now it allows for you to have the same. So this is where polymorphism comes in. Allows a class to have multiple methods. So this method is being used multiple times. Calculate area. Yeah, it is being used multiple times. It's being used with calculating the area of a circle and the area of the rectangle. Well explained. Any question?
Sir, excuse me, sir.
Yes, I'm listening.
I don't think in this case we are using anything like overloading. I feel like it's more of overriding.
It's more of okay. Let's
overriding. It's not overloading.
Okay, let's look at one more example in overloading. It's more of overriding. Let's try to get one more example in overloading.
Easy.
Okay, so that it could help to differentiate that. So let me use it in a more different way. I hope it okay.
Sir, if I may, according to like I was looking here for an example of overloading. It turns out Python doesn't do traditional overloading. You know, like for example in Java, where you can define a method twice in the same class, and then you say if it takes 2 parameters, it does this. If it takes 3, it does this, which is the overloading in this case. For Python, when you do that, they take the latest method you've defined. They ignore the first ones, so it doesn't support overloading.
Okay, probably. Can I have more? Let's spend like two more minutes on it, so that we are on the same page. Yes, Owen.
Like it's also the same way I'm also having, like it cannot actually, if you define like two or more methods with the same name, but in different parameters, if you try to call one, whereby, for example, if you try to call the first one, whereby with no arguments, because I had made the first method with no arguments, it will require parameters of the latest method that we declared. For example, if the third method is your last overload method, with maybe 2 parameters, it require you to parameters before consider.
No, this time I will be working, but I will be working from home.
Who is that one?
And I feed my cows.
There's someone who should mute.
So I think overloading.
Okay.
Sir. Let me. How about this? Wouldn't this? I have a sample code that I've done. Can I share the screen and maybe, because I think this illustrates more of the overloading.
I actually know how to implement it, but you share your screen. I wanted to first hear from people.
Yes. So it's just following that same example that you have given.
Mm,
We're having a class shape, and then it
mm,
is having the method area.
mm,
And then instead of creating the constructors for the circle, you are just redefining the area, because overloading, you change the method definition and the method body. So by changing here, the method definition and method body, we are doing overloading of the method calculate area.
mm.
That is same applies for the rectangle and this, such that here you just assign the parameters when you are calling these methods to be printed on the screen.
But like according like to what Doctor said, like it's the same class but with different methods with the same name of the method. For example, in a class, for example, maybe shape, it will be having different methods with the same name, and the only thing that will be varying will be parameters. So there, you're like, we also have to use inheritance while implementing method overloading. But according to the statement Doctor made at first was like, it will be in the same body or same class, then, but with different parameters.
Okay. Let me give you a simple example, because sometimes when you all introduce some concept like that, a lot of people tend to, I don't know, I'm trying to get back to my, okay. Let's have it with a simple example. You know, I prefer explaining most of these things using, we are now understanding the whole concept of overloading. Not so? Class. Let's first understand it in Python, because most of you have, okay, let's look at it in Python. Basically overloading. So now, how it is, the thing is, I don't want to, let me just use a simple, let's just deal with like numbers, and then we use operators. Then I will explain to you in a simple way for you to understand this overloading concept in Python. Let's have a class for calculation, like to calculate a class just to like maybe like something that calculate, or a calculator thing. Okay. Now, in this class, when we define this method, let's say we have a method which is adding. So we have self, then we can have xy. Okay. Now our xy, we can now return xy. Now that's the first method. Now I want to go back to this statement that I made here. Allows a class to have multiple methods. Okay. So in polymorphism, it allows you to have what? Method overloading allows a class to have multiple methods with the same name but different parameters. With the same name but different parameters. So this is what I'm trying to mean. Same name. If I do this, this is a different method. It's a method for subtract. But what I feel like is that if I put here add, this is now the method with the same name. Now I can change the parameters. I can add, then I can put like maybe C. Then it can return X plus that. Now, this is how we implement polymorphism in Python. Okay, this is what I know, and I think it's very right how you implement it. Now, because I'm reading this statement, guys, help me. Let's read this statement together. I know I've been reading Python a lot, but I actually know Python very well. When you read this statement, overloading allows a class to have multiple methods with the same name. Now let's go to this example that I'm giving. That's why you see Copilot is not even now suggesting. There's no error, but it's just allowing me to do what I want to do. Because now you see the method is having the same name. Then with the same name, but different parameters. Let's look at the parameters which are here. There are different parameters. This is just XY. The next one is XYC. So if I allow you to be in control of my class, I would be making a big mistake because you mislead everyone now. Now, that is why I put that statement there. And you're all agreeing with me. You're not complaining. Now I can create object, which we have been doing. Let me create object. I don't want this code to be long. Let me create object, calculate. Okay, sorry. Copilot was helping me. Okay. So we can have calculate, add. No. I want to implement it in a different way, Copilot. Calculator with that method, calculate. So how did we write? Okay. We've written it with lowercase. Can I change this to uppercase? You know, Python is case sensitive. All right. So now let's get the output. Invoke the function. No. Let's just display output. I don't want to use words that are confusing. So I like explaining most of my stuff using. I think I can agree with that. But I can have the value of X different. I can have maybe 7, so that I put a higher figure, 7. Okay. Now, you see, I have the same method with the same name, but I've passed in different variables, and I'm still able to get what? The output. Do trust me. When I run that, oops. When I run that,
Sir.
Okay. I've understood. Let's just put what I don't know why I was even changing the stuff. Let's first do this. Then you will come back with the position. What's missing here?
So, like, it's actually calling the last decade method with add. That's what we are saying at first. Like, it won't be supporting the overloaded thing, unless maybe you are to use inheritance as Brian. I'm sure that's earlier.
So,
okay.
The thing is, for Python, it calls the last declared method. The method you declared last. It's what's called all the time. And the only way to implement this thing is if we are going to use our default parameters, maybe, where you like put 3 parameters, but then you declare them, you give them default values or something like that.
Have you implemented it?
No, I haven't yet. But
Okay. Yes.
Like I've tried out one whereby you give one method and you pass, let's say, 3 parameters. I've put it in the chat. Then the other parameters, let's say, I can use an if statement because basically on my research, method overloading in Python, basically like implementing it. If you can check through the charts, I can use an if statement whereby, let's say, if I pass 2 parameters, this is what you return. If I pass 3, this is what you return. So you can basically implement that by, so it will be the compiler to read out which method to call.
Yeah. But now what have we picked from this concept?
But according to what,
it is still method overloading.
like according to what you are
You've just
in the chat,
summarized everything. It's just
actually you're using
method overloading.
Excuse me.
Mm.
So what you're doing is a traditional what overloading, which doesn't exist in Python. Because if I can share my screen, the alternatives that can use to do method overloading.
You share. Share the screen, eh?
Yeah. So this is not in the editor yet, but this is what I got from this platform. So they're telling us that we can use the default parameter here to implement that functionality, or we can use this args what parameter here that takes in a given number of parameters and use if statements like what we were trying to say, and with that we can control the number of parameters in here. If it is 1, then we do that exception. If there are 2, like that. But
okay. Now let me guide. It's okay. I thank all of you for your input, but let's not forget that we are under inheritance. Using what? Just get back. Let me share my screen. I appreciate all of your effort to make sure that we have something for us to understand here. But now the confusion comes in when we start. We are basically looking at what they call polymorphism. So what we said clearly that it allows method overriding. It allows a class to have multiple. We just demonstrated here that we can have the same method with the same name. That's the concept we are implementing. Okay. So I think you know how overloading is being implemented. But I also agree with all what you've added into the chat. Yes, I've been using the traditional method, and of course you can't run away from explaining the concept using the traditional method if you really want people to understand the concept of overloading. So, but basically here what we are interested in, does it allow you to have the same name with different parameters? Just answer that. Does it allow you to have the same name with different parameters? Either a yes or a no. Does it allow or it doesn't?
It allows according to what we are seeing. Only that when we go to print out the output, it doesn't.
It doesn't.
So that's where the challenge comes in from.
Okay.
Like say it allows, but it will call the last method defined.
It will call the last method defined. Okay. All right. So that is it.
So
it will call the last method defined. There's no more
So
question there.
I
Yes.
think it allows, but I think the issue there is that we have a compile time error more than a logical error. So when you're writing when you're writing the code, when you have a logical error, unlike a compile time run error. So here, when you're writing the code, the compiler actually will look at the code, and the code is right. The code is right, but when you try to run the code, you get a runtime error.
So if we are to experiment this, if you try removing that method of add with the two parameters, the first one, you will see that our code will run because the last method we defined was the one that had 3 parameters. So if you remove one that has 2 parameters and you run that code, I'm very sure it will run and it will bring the output.
That is very true. That's very true. But we would have not yet what? Explained the concept of polymorphism. Just understand the concept. I think nothing much. You know how to implement it. Let us now look at our last key concept, abstraction. There are many concepts under that. I've tried, by the way, to cover all those concepts compared to the previous recess class. Okay. So sometimes the concept, but that is it. That's the concept of polymorphism, which no one is complaining. It's just that the output doesn't what? Display. But we have understood. So let's go to abstraction. So I'm also going to explain this. Let me try to pick keywords to guide in the explanation so that we do not, let me comment this because you now know the word output won't come. So if I try to run anything in the terminal, I'll definitely have that error. Okay. All right. So let's see how we can understand abstraction. So let's also let's pick out the important points that we need to understand on abstraction. Abstraction, one, it allows you to focus on essential features and hide them from unnecessary details.
So
yes.
Before we go to abstraction, I had kind of lost my connection, but I wanted to share something.
Okay. Just know that our time is going to. Okay, let's try. Share.
Okay. So according to what I've been trying to do here.
You share your screen.
Yeah, it's there. So when if we try something like instead of doing the normal
traditional way,
we could use something called the default parameters. Now, for example, if you look at this method here, the method add. So I do the normal implementation, but then I give each of them a default number, like a default value. For example, number 1, I gave each of them as 0. So here, when we come at the end, I can implement both the methods. I can give it 2 parameters or 3 parameters. What it does is it's not overloading in this case of the actual definition, but it works like overloading in that when you give it 2 parameters, it takes the last one as the default value you gave here, which was 0. And yeah, the results come out quite well, 5 and 10.
But you first repeat the statement. You said it doesn't come in
No,
the
it's not the
context of overloading.
It's not the ideal overloading we are looking at, like in any case of like Java or that, but it does the same, like it's a workaround.
It just just a workaround to display. Nice.
Yeah.
Thank you. But I think people have picked this concept. That's what I believe, because no one is complaining in the chat.
I have
Any
a small suggestion.
Okay.
From Joshua's work there, he's only dealing with arguments, not parameters. Overloading is with the change in the number of parameters, but there it's only changing the number of arguments that are given when the function is called. So that's the difference between the use of the default parameters and overloading.
As Livingston covered arguments, like how to pass in arguments, but yes, I think he did. He did. Okay. So I think that's clear, because you see it's just passing in the arguments. Okay, Kato, Trevor, you guys want us? Okay, I'll give you an assignment on abstraction. Yes, Kato? Unmute and then we proceed. I don't want.
Sorry about that.
Okay. Hey, Kato, what happened?
Yeah, I gave my input about the arguments.
Okay. So let's do one more example. I give you one, you try it, then I give you an exercise on that same concept, and we call it what? We call it a Friday, because we've covered all those things. So continue. Yeah, but it's good. It's good to allow people what? It's good to allow people to participate. Okay. So what we're trying to say here is that abstraction allows you to focus on essential features and hide them from unnecessary details. I want us to try to look at one example, how we can demonstrate abstraction in a real scenario. So there is okay. Over example 5, we have so many examples. I don't know. This is over example 5 or 6 or 7 example. Okay. Let's demonstrate. Let's demonstrate abstraction. Okay. So how are we going to demonstrate abstraction here? The abstracted method, in most cases, it's like you're importing a module. So you do, I'm going to first use it in an example form because it's easier to understand it, as it has proven to be our ways of explaining things now. So import ABC. So you can see tab 9 is trying to recognize that. Then you just can say, just to explain, this is called what? Abstracted method. Abstracted method. Okay. As long as abstracted class method, it's okay because we will be dealing with classes. So let's try to say we could have it in animals, but let's have it in something maybe not different, but still the same idea we implemented. I'll do one, then you try one. So we can pass in the abstracted method here. And what is the abstracted method? Is ABC. Okay. Now, what you need to know is that okay, let's define the method itself. So this is how you implement abstracted method. So abstracted method. I hope it won't complain. What? Okay. Can I comment this? It might affect, I don't know. Abstracted method. So define this method car. So we're passing in self. So we have the method here for start. Starting a car started, car stop, then car moving, car stop. Something simple like that. So let's have that. Let's have car start, then we can still also do one more abstracted. Yeah, car stop, yes. But still this for people to understand. I don't want to abstract it. It's complaining.
Excuse me, sir.
Yes.
You imported abstract class method instead of abstract method.
Hey, that's why it's complaining.
Yeah.
Okay. So when I remove doesn't complain, eh? Okay. Okay. Thank you. I was wondering. Okay. It was that copilot thing which suggested. So this is how you implement the abstract method. The car stop pass. So we can now have another class. And we have a class for car. What did we have? Well, we had vehicle. So we could have vehicle there. So what we're doing here is that in our child class, we're passing in the class for the superclass, the superclass or the baseline class for vehicle. So we are now defining to starting the car, which is okay, that output. Then we could also have define one more for stopping the car, okay? Then we can now have another class because that's just can have another class. We have vehicle, we do truck. Okay, truck. So vehicle. Then we could still have starting a truck. Nice. Method for starting a car. So we can also have stopping the car, stopping the truck. Okay, nice. So let's create the objects here. Create. We first start by creating the first object, the vehicle object. let's create the vehicle object. So can have car. For car, then we can have truck for truck. All right. Then we can invoke the method. No, let's just start and stop vehicle. Start and stop truck or vehicle, because all of them are vehicle. Cars and trucks are all vehicles. So let's start the vehicle. So how do we start the vehicle now? It has suggested that, which, so I think could be, this could work for us. So let's try it out. Okay, let's have the display. That displays the first part of the car. So this is what we call abstracted method. Okay, when you point on it, yeah, it's a method that allows you to focus on essential features and hide the unnecessary details. So you see, we have decided to hide maybe like the detailed info of the vehicle. So we are now just focusing on the detailed part of the information. So now let's try to run that. Car started, truck started. Yeah, I think that's super cool. Let's try to check it if it stops. Stop vehicle, Then car. So for stopping, could also have that. Stopping the truck, stopping the car. So this is how you deal with abstraction. Now I want to give you a simple assignment. No, okay, exercise, then the assignment later. You'll share your screen and explain. But this is how you implement abstraction. All right. The concepts are many, but we can exercise. Let's have exercise. Okay, 1, 2, think 2. Let me try to. I'll use the examples that you've been using so that it doesn't become very what? Doesn't become very difficult or.
Yes, I have a question.
Yes. Yes, please.
So is it necessary to be importing ABC from ABC?
Yes, it's necessary to be importing ABC from ABC. If you don't, it won't be an abstracted method. Just like even this example that I'm giving you. If you don't import that, and abstraction is as simple as that. So demonstrate, okay, just exercise. Demonstrate abstraction using, of course, it doesn't take long because you have the code already. You're just going to reuse it. Demonstrate abstraction using calculating, just calculating the same thing, calculating area of a circle, area of a circle and rectangle. Okay, that is it. You should be able to work. There's a comment in the chat. Let's see what. So may you please share your code for our, may you please share your code for review to our emails? Oh, all my codes. I'll share. I'll share. I'll try to share it. Okay. I know some people have not been writing. They just want to take notes from the code. I'll share. I'll share with you. I think I'll share with you, or I send it to Doctor. Doctor will forward it to you. But I will share with you all my codes. All right. So try out that. Share your screen. And yeah, unmute, explain. Then I will give you the exercise. The assignment, sorry. I'll give you the assignment. Share your code. This time, let's have 4 ladies, no, 3 ladies and 4 gents. As you register, you know, today I've taken a long, because I never wanted to waste a lot of time. That's why we had only 1 break. But I must say that we managed to finish what I planned for this week. Share your screen and explain as I create the forms. I create the form, then I give you the assignment. So we are almost finishing all these concepts in Python. I think on Monday I will be done with all the concepts. Then we are going to start learning some bit of installation on our next data science thing, because the machine learning is quite big, so we might start it much earlier. The good news is that we have covered most of the things in the first and the second week. It has never happened on record, but this is a good record. Please share your screen. Oh, you're still working. You're still working it out? Are you still working it out? Share your screen. Once you're done, share your screen. Guys, share your screen and explain.
Hope my screen is visible.
Yeah, go ahead, explain.
So here from ABC, I imported ABC, and then this is my class shape. Then I pass in that this is an abstract class. So I have a constructor which is taking in the name. Then I declare my abstract method of area by using the pass keyword, meaning I haven't defined anything for the method area. Then using inheritance through the classes of circle, which is a subclass of shape. It also has its own constructor, which will actually override the first constructor of the base class. Then to call the name of the first of the base class is the super function. Because the circle class is taking in the name and radius. So for the name case, I want to be using the name passed in from the base class. That's why I use the super function. Then I also declare my radius. Then I actually have to define the area. Remember here I didn't define the area method. So in the circle class, I define the area whereby I'm returning the formula, which is radius times pi. Then I also have a class for rectangle, which is also subclass of shape. This has also its constructor taking in name, width, and length. So still accessing the name of the base class, so I use the superclass. Then I also declare the width and the length. Then it also has its own area, and this own area to be width times length. Then I create the circle object. Since it has a constructor, that means on initialization, I'm able to pass in the parameters, the name and then the radius. Then I try to print out or to print out the answer when I invoke the area method inside the circle class. Then also create the rectangle object, pass in the name, then the parameters of length and width. Then also try to print out the result when I invoke the area method inside the rectangle class. Now when I try to run it here, so these are for cast it was for the first two. You can see here the area. The area for the circle it will be 153.86. Then the area for rectangle it will be 48.
Okay, thank you, Owen. Please, guys, use emoji to clap for Owen. Let's have a lady to share, also explain. By Zahara. You're going to be my good friend because I like active people.
Hello? Can you
Yes,
hear me?
Sarah. Yes, I can hear you.
Okay. So demonstrating the example of calculating area and parameter of a circle and rectangle. Well, from ABC import ABC. This is enabling us to have the abstraction in, and like I used later in my previous method, I had to import math to enable me use the pi since it's a constant in the module math. Then I created two abstract methods in the class shape. Of course, when you're doing abstraction, since I imported ABC, I will have to pass it in as a parameter in my class shape. Then abstraction is all about hiding the internal implementations of a method. So that's why I didn't pass in anything in here. I just used the word pass since I didn't want to pass in any methods or rather any details of a method. Then I created my subclass called circle, and this is its constructor. Then this is its method. These methods, the abstract methods, should be or must be implemented by the subclasses, because if they're not implemented, it will throw an error. So I had to implement both the methods, the abstract methods of my parent class shape. Then the same applies to rectangle. I did the same, but its constructor was quite different. Since for it takes in the length and the width, but it also had to implement the what? It also had to implement the methods, and it had to give them the details since they were abstract methods. So when we're implementing them, we shall have to give them details. Then I had to create the instances of those classes and passed in the arguments. Then I printed out by invoking those methods that I had already created. And when I run it,
okay. I see you have 9 problems. Which problems are those ones? Are they related to this last code? Just under problems here.
The problems be like naming, those ones, like if I put a name like Zahara, things like that.
Okay.
These are the problems.
Okay, no, that's okay. That's fine. Okay, well done. I think you've been an active student for sure. The girls should really clap for you. Use some emoji for our girl. And she's a leader, class rep. Those are the qualities of leaders we want. They lead by example. She's an amazing person. Yes, Trevor?
So mine is not so different. I start with a class called shape, which
I've seen you've implemented something quite unique a bit. Do you understand when you say import, then the asterisk?
it just means that I'm getting everything from, from that module.
Yeah.
That's what I used. So
okay.
yeah, I use this that first statement to get everything from that module ABC. Then I make shape to inherit from the abstract base class so that I'm able to implement abstraction with the method calc area. I have two classes, circle and rectangle, which also inherit from the shape class. And they have different implementations of the same method. There is the calc area, which gets the area of the circle accordingly with the pi times radius to the power of 2. And then for the rectangle, to get the area, get the product of the width and the length of that rectangle. So I create the objects and then I invoke both of the methods. And the output is that which is shown in the terminal. Thank you.
Okay, thank you, Kato. Now let's have one lady. A lady. Then I give you the exercise. No, the assignment. One lady, then I give you the assignment. So I'm sharing a lady. By any chance, do you have any lady who is going to share? By any chance? Because if it is not Sarah, then it should be, is it Kathy? Kathy, what happened today? The rest have already switched off, eh? It's too early. It's too early to switch off. Okay, assignment. You will send the assignment tomorrow by, you send the assignment tomorrow by what? Guys, register. You know, I'm about to switch off to turn off the registration because it's already midday and we are already past, but just to summarize. Okay, first, how to name your file when you're sending it to me. How to name your file when sending on my email. On my email. My email is that one. It's missing .cs. Okay. This is the only format which I'm accepting. Some of you still don't know that you're giving me a lot of work. Accepted format is just only one format. Just write your name like the way I'm writing this. Should be your surname. Hey, should be first name. First name. Should be first name underscore. No, it should be. Yeah, it should be. Yeah, first name underscore last name. Then morning. .py. Then the one for Livingstone in the afternoon, it's supposed to be that afternoon. This last name is surname. Let me just put words that are simple, so that you don't blame me that I've not marked your work. Because when you download those files on the computer, you don't again have to go and rename them. You just download, copy all the files and put it in one folder. Because I want to be marking your work as we're moving forward. Okay. So if I don't mark your work, don't blame me, because I'll only download files of this format, download them, then look for them and give marks. Anything which is not of this format, I'll not mark, I'll not, because when I download, I will not know. If you maybe send a work like 1.py, how will I know one? On the email, yes, I know it is you who sent. But once I download it in the folder, I will not know. Yeah. Assignment. Create a receipt. Printing. I don't know over one for today, over a minute. What's the date? Tomorrow is what? Okay. Tomorrow is first. People have been asking about deadline. These days now, I think it's better to write everything. Create a receipt printing. Create a receipt printing program with GUI interface. Okay. Who is the class rep? Zara. That is the assignment. Create a receipt printing program with GUI interface, a more advanced point. I don't want people to over ask questions on this simple thing. I'm going to post them in the chat. Okay, that is it. I'm going to post the assignment in the chat. And you. So that is the assignment. Oh, no, something is missing. Okay. I think you have said I've saved myself, I've saved Doctor from all those queries. Yeah, I think now I can peacefully hand over the session to Doctor. Doctor, over to you.
Sir.
Yes.
Excuse me, sir. Before
Yes.
you go, I wanted to inquire about something. You know how like for example, you know Dart, right? The language. In Dart, there's something called named constructors. Do they also apply in Python?
Name constructors.
Yeah.
Yeah, it's applied, but let me see if this is me handling that particular concept, but I'll try to respond to it on Monday.
Okay.
So I also have a concern about about the namings of the document we're supposed to send you. You're saying we write first name, surname, then morning. So on our side, on your side, sending it is easy, but on our side, it means that we are saving all those documents the same way, like that. So it will bring in corruption. Like in our, I cannot be saving all my work first name like this. There is it's going to indicate that there is an error.
Okay, can I help you out?
Yeah.
I'm solving that problem. So the A is always the assignment name. If it is assignment 1, assignment 2, that's how we will be what? That solves the problem, right?
Sir, excuse me, sir.
Yes.
What if we just include the day of study? Like, for example, today is day 5. We just include
Please
day 5.
don't do things in a different way. I can show you what I'm talking about. I'll show it to you on Monday. I'll show it to you on a Monday. First, do the right thing the way I want. Any more question?
Nothing.
Okay, over to you, Dr. Ruth.
Thank you, Geoffrey, and thank you, class. You were an engaging class. Again, Geoffrey is very happy with you. Very optimistic, which is nice. We look forward to seeing the projects that are going to come out. So let's go for a break. We shall come back at 2. Yeah, see you in the afternoon.
Yeah, you could stop the recording as well.